So today we are going to focus on the standard normal distribution, or the Z-curve. Totally new information. I encourage you to go ahead and get out your notes. These are the exact same notes that I uploaded over the weekend for you. They're posted under Content, Module 4, and Pause. That way you can print it. I know some people last week said it was kind of hard a little blurry, and I'm sure it is because I'm holding my phone, which is my camera, as I'm talking, and I'm sure it moves around some. So I encourage you to have out your notes, just like you would in class, and then kind of view this as the overhead projector and look up as necessary. So starting out, we have the Z distribution. Let me kind of zoom in here, and hopefully, again, pause it if you need to, go get your notes and print them. If you notice, a Z distribution or a normal distribution is a mound-shaped symmetrical curve. I'm in the habit of drawing these very quickly. You can too. They won't look perfect, but just keep in mind key facts. It's mound-shaped symmetrical. I have the key facts listed here. It's mound-shaped symmetrical. The mean is always in the middle. And for the Z distribution, see, this is now our Z-axis instead of our X-axis, okay? And I'll show you what that means in a minute. But the mean is always 0, and we move in increments of standard deviation. This says mean plus 1 standard deviation, mean plus 2 standard deviations, and the standard deviation always equals 1. So if we start in the middle at 0 and move 1 standard deviation, we're at 1. The mean, which is 0, plus 2 standard deviations is 2. And again, moving 3 standard deviations is 3. Same thing happens the other direction. And you notice, as you get more than 3 standard deviations away from the mean, this area between the curve and the lines, very little. Beyond 3.5 standard deviations, again, these are the number of standard deviations you've moved from 0. Beyond 3.5, the area under the curve is basically 0. So again, key facts, it's symmetrical. The mean is 0, okay? Standard deviation is 1. The total area under the curve is 1 or 100%. Okay, with that in mind, if you fold this in half, if it's symmetrical, you're going to have the same amount of area to the left of the mean and to the right of the mean. If 100% is the whole thing, half or 50% lies to the left of the mean, okay? And half or 50% lies to the right of the mean. So what percent of the area is less than the mean? 50%. What percent is greater than the mean? 50%. Okay? The last thing I want to focus on is the formula for Z. So Z is equal to the number of standard deviations between your given X value and the mean of the distribution. In other words, X minus mu over sigma. Sometimes we're given X and told to find Z. Sometimes we're given Z and told to find X. If you're given Z, this is the same formula rewritten. Okay. Now let's do an example using this formula. Again, please be looking at your notes because there's no way I can get this whole sentence in here without it being blurry. So a test has a mean of 1495 and a standard deviation of 318. The test scores, and the test score is your X. It's always important to look at the problem and see what is your variable. In this problem, it's the test score, okay? And I even wrote the X there just so we wouldn't forget that. Okay, so the test score of one student was 1890. Find the Z-score that corresponds to 1890. In other words, we're going to use this formula. We are given X, mu, and sigma, and we're going to find Z. So what we always do, in every problem, write down your solution. Okay, in other words, write down what you know. What were you given? And maybe I probably should have used the word given here because we were given this information. The mean was given as 1495. It says it right there. Mean score of 1495. Okay, standard deviation, it says it was 318. And our X, the test score, that's your X, for one student was 1890, okay? That is all of our given information, and we're told to find Z. All we do is plug these values in. Recall this formula, X minus mu over sigma. Well, X was 1890, mu was 1495, sigma was 318. Plug that in your calculator and you get 1.24. Okay, be very careful when you put it in your calculator. You want to say 890 minus 1495 equals, then divided by 318, or put parentheses around this. Very, very important. Okay. Now, what does this mean? What would this look like? If I told you to graph Z equals 1.24, where would that go? Let's look at the top. There is 1 on the Z-axis. There is 2. 1.24 would be about right here. We're just estimating it, but just kind of showing you what that really means. Z is just a value on this axis. We're used to dealing with the x-axis, now we're dealing with the z-axis. Again, hopefully you have your notes out, and please feel free to pause as necessary. I want to go on to example 2. Okay. Find the area in the shaded region or the probability that z is less than 2. That's what that says. So if we look here, I have shaded the area. This is the z-axis again. I've shaded the area where it's less than 2. Area and probability are the same thing. So the area to the left of negative 2 is the same thing as the probability that z is less than. Less than points to the left. That's the area to the left. This is the picture of that probability statement. So important. Okay. Looking back at the number line, everybody knows that on a number line, it extends forever. So just looking at this side, it goes all the way forever to negative infinity. This side goes all the way forever to positive infinity. Keep that in mind, because the way we find this area, we're told to find area. We find this in our calculator. I know MyLabs Plus gives you a z table, but I'm going to show you how to do it in the calculator, because you can't always use a z table, but you can always get the answer in your calculator. Okay, so let's look at the solution. To find this solution, our calculator needs to know our boundaries of our region. So for this region, I'm going to put 2 fingers up here. My left finger is on negative infinity. My right finger is on negative 2. Okay? Always touch it. For some reason, students have a really hard time doing left and right boundary, but if you are even finding boundaries in general, it's almost, I think most students skip the picture, try to go straight to the calculator, and get it wrong half the time. So always draw your picture, put your finger on your boundaries. That will keep you from making that mistake. It sounds silly, but it will save you lots of points. So negative infinity is my left boundary, negative 2 is my right boundary. Your calculator does not have a negative infinity button. So we need to use a number that will mimic or represent negative infinity. In other words, some large negative number. I'm going to use negative 9999. You can use negative 10,000. It doesn't matter. Okay? Because remember, the area under the curve, what you get way out here is 0 anyway. And we're finding the area is what we're using. So let's look back here. Our left boundary is negative 9999. Again, I just explained that. My right boundary is negative 2. The mean of the z distribution is always 0, and the standard deviation is always 1. Those are the 4 numbers I need for my calculator. We plug this into the calculator using second bars, normal CDF, and then you enter negative 9999, negative 2, 0, and 1. Okay? So again, second bars, we've used that before. Normal CDF. C stands for cumulative. Cumulative area always means area to the left. You will see that in a lot of problems. You need to remember that wording and that terminology. Area to the left of any number is a cumulative. You're accumulating, adding up the area to the left of a number. So normal CDF, C for cumulative, your left boundary, comma, right boundary. Make sure you use the negative sign, not the subtraction sign. Comma 0, comma 1. Your answer is 0.02. I'm going to end this video so they don't get too large. And on the next video, I will actually demonstrate how to, I will hit the buttons in the calculator. So we're about to, this is examples 1 and 2. I'm going to do examples 3 through 6 in the next video.